This chapter was going to be about integrating the gverb free reverb code, but I'm going to postpone that because I want to talk about DSP algorithms and specifically the CMSISDSP library. I'm interested in using the CMSIS framework, which is developed by ARM as a standard set of APIs to interface to the various ARM Cortex M processors, and this means that essentially the same code will run on various different ARM Cortex processors. And in particular, I'm interested in the DSP functions because you've got some maths functions, DSP, fast Fourier transforms, that kind of thing, and they're specifically optimized for the various ARM Cortex processors. And in particular, in the Pico 2, we've got a dedicated FPU, floating point unit. So if I use the CMSISDSP library and I tell it that I'm using a Cortex M33 processor, I'm going to get optimized FFT functions, for example, optimized for the ARM Cortex M33. I've got a program here. It doesn't actually matter what it does, but it includes the math.h, the standard C maths library, and this builds fine. If I build it, no problems. But I know that if I want to get access to those CMSIS fast maths library, I'm going to need to include ARM math.h, and just save that. And if I build that, it can't find it. So what I'm going to do is just explain what you need to do so that the code can find and include ARM math.h. When you clone the Pico SDK, and I've cloned it into a dev tools directory on my F drive, you'll find in here under source rp2 common that there's a CMSIS directory, and that's because CMSIS is included in the latest Raspberry Pi Pico SDK. But we have to tell our code what to do with that and where to find it. The changes we need to make all happen within the CMake lists file. So here I've got my Pico SDK path, and that's pointing to, in my instance, it's my fdevtools Pico SDK master directory, which is where I downloaded the Pico SDK. Your mileage may vary. And then into here we need to add this. So this is setting another environment variable, temporary one, called CMSIS core, and it's setting it to that CMSIS, to a subdirectory beneath that CMSIS directory that we just looked at on my F drive. And then what it's going to do is include some, and it's going to fetch some additional content, and it's actually going to go during the compile process, it's going to go to GitHub and it's going to download or clone a Git repository. And specifically, as of January 2025, the latest version is v1.16.2, and by supplying a Git tag, it's going to ensure that we pull down that particular volume, and then it's going to make it available to the compiler. Because I want to use the DSP functions, the next thing I need to do is, in the target link libraries, I need to include this file, which is the libcmsysdsp, and as we'll see in a minute, this will be built when by virtue of the fact that we've pulled in that Git repository, this will be built when I recompile. And then finally in here there are a couple of other include directories, or directories that need to be included. So one under the CMSISDSP source, and this one which is way down beneath that CMSIS directory that we saw under the Raspberry Pi common directory. Whenever you make changes, structural changes to the CMake lists.txt file, always a good idea to delete the existing build directory, because it will all be recreated as soon as the the program recompiles. So then need to save my modified CMake lists file, which will create the build files, and then I can build it. And what we'll see here is it's building, compiling all of the source files beneath this CMSISDSP library. So this is where it's going to recreate that CMSIS libcmsysdsp.a library. And there we are, and that's built correctly. So now my main.c, it's not complaining that it can't find ARM math.h. So we have successfully built and linked the CMSISDSP library with our C source code.